Good morning, students. Today we're going to discuss a case study on maximum flow problem um, and the subject design and analysis of algorithms. The maximum flow problem is a problem going to solve by iterative improvement algorithmic strategy. The maximum flow problem, the name itself, we can identify the problem. We can identify how much maximum possible flow in a particular material. Okay, so here before move to the problem, we have some real time examples where we're going to apply this problem. The first one is that is a road traffic in road systems. Okay, this is the first example. For example, if you have a two-way road, so what is the density of vehicles over the road? If we have a four-way or six-way roads, so bypass roads mostly a six-way roads, some of the NH may be a four-way roads. Okay, so the density of vehicle will be increased based upon the road size. So the maximum flow, the if that it's a two-way road, vehicles only, limited vehicles only passed at a time. Okay, so that is a flow of vehicles is minimum if it's a two-way road. If it is a four-way road, the density of vehicle will be a more. Okay, so that is a flow, traffic flow, traffic in a road systems. Another one is once again, sorry. Let's next example is a fluid in pipes. What is the maximum flow in a pipe? Okay, fluids. The based upon the size of a pipe, the flow will be varied. Okay, if the size is maximum size is only possible to flow 10 liters, means we can't pass it as a we can't make it as a 12 liters through this. Okay, next, currents in an electrical circuit. So what is the maximum flow of current in a electrical circuit? And another example is a packet traffic in a computer networks, the number of packets. If the system is able to transfer only a 10 packets at a time, we can't send it as a 12 packets. So that is a traffic flow in a computer. So for all these kind of problems, we have a only one solution called a flow network. So I can define a flow network by F by C. That is nothing but C is a capacity, F is a flow. The flow will not exceed the capacity. That can be defined as a directed graph where each edge has a capacity and each edge receives a flow. Okay, the amount of flow on edge cannot exceed the capacity of edge. This is the flow problem. Okay, so a flow must satisfy the restriction that amount of flow into the node equal to amount of flow out of it. Okay, so here example, if I can able to pass only a 10 here, I can't able to pass 12 using this A to B. I can able to pass 1, 2, 3, 4, up to 9, up to 10. You can't pass 11. So to implement this, we have a three different things: source, destination, and capacity. The starting vertex is called a star source, and ending vertex is called a destination. And capacity or a weight is nothing but a weight of an edge. Okay, maximum flow problem can be defined by optimization theory problem, because it's an iterative improvement. It's using a maximum optimization theory problem, finding a feasible flow through a single source and a single flow network, that is the maximum. For Fulkerson algorithm used to implement the flow problem. Okay, a graph which represent flow network, every edge has a capacity. Here the source node is called as a S and the sink node or destination is called a T. So find a maximum flow S to T with the following constraints. Flow edge cannot exceed the capacity of edge. The inflow is equal to outflow for vertex except S and T. Okay, the algorithm is nothing but step one, start with the initial flow as 0, while there are an augmentation path from source to sink and the path from flow to flow, then return a flow. So here the terminologies regarding this maximum flow problem is residual gram, residual capacity, minimum cut and augmented path. So residual graph is defined as an additional possible flow in a graph. Residual capacity is the original capacity minus flow. Minimal cut is a maximum possible flow is called a minimal cut. Okay, so here minimum cut is nothing. Here maximum possible flow is 3, that is called a minimum cut. Augmented path will be selected as a non-full forward edges and non-empty backward edges. So this is an example solved by using this problem. I will explain during the tutorial hour. So uses of this maximum flow problem in a computer network. It is a technology impact, modern lifestyle, advertising civilization, flow raising networks. Network optimization problem is used to find a cost based profit and supply based demand and network optimization. Okay, so that's all about this case study. Okay, thank you.